Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello and welcome everybody to Pepperl+Fuchs Plugged In. Today I have again with me Eduardo Bustillo. Hi, Eduardo.
Hi, Helga. Thank you for having me today.
Anytime, Eduardo. I think you have a great product for us. We briefly talked before we turned on the microphone. We briefly talked about the product. What is it that you brought for us today?
Today, I'm going to be talking about our safe inductive sensors, specifically our safe mobile equipment inductive sensors.
Okay, so a couple of really interesting key terms in there: safe, and of course, mobile equipment, which is a demanding market. That's a rough environment.
It's a rough environment. It's a really tough and hazardous environment. So it's really hard to make tough, rugged products that fit that type of environment. But we found a way.
Great. So let's start with a very basic one, simple one, important question. Why is this an important product for our market?
For our market specifically, safe inductive fits really well. Pepperl+Fuchs is a leader when it comes to safety electronic equipment. We have so many safe products right now with our light curtains, with our safe ultrasonic, safe positioning. So safe inductive fits perfectly right in there.
Okay. And clearly that's great for a customer, but what are the benefits our customer get from using a safe inductive sensor on the one hand and our safe inductive sensor in particular?
Well, in general, ours are a lot more flexible when it comes to installation and when it comes to applications for specifically safe inductive sensors.
I think I know where you're going with that statement. You're going in the direction of the very definitive state, the very clear situation when the sensor is on and when the sensor is not on, because not every product on the market is quite so definitive. I think that's what you're talking about. Can you get into that a little bit, please?
Yeah, definitely. So for safe inductives in general, they have a much higher level of reliability, especially compared to a standard inductive sensor. And specifically for our inductive sensors, one thing that we talk about all the time for our inductive sensors is they don't have, for example, a deadband. That makes it a lot easier for the user. When they install it, they don't have to go back and forth and get the positioning just right. They can ensure that when that sensor switches, that there's a part right in front of the sensor. If it did have a deadband, you may or may not know whether a part is too close or too far. It would have to be right in the exact range of that sensor. And for ours, without the deadband, if you get a signal, you know there's a part there.
I think that's very important, because in a safety system, when the circuit is released, then a machine would be operating, and when it's in any other state, in the non-release state, it shouldn't be operating. And so, in our case, if I hear you correctly, then there's only two scenarios: it's in range up to the face, or it's outer range. And it's not like, it's a little bit in range and a little bit outer range. It's very definitive.
That's right. It's very definitive. So once you get a signal from the sensor, you know that there's something there.
Or not.
Or not, right.
No question. You know exactly where things are.
Exactly.
I think that's very important. Now, talk a little bit about the mobile equipment aspect. You said it's a really tough environment. What makes our sensor shine in that environment?
Right. So mobile equipment, in general, it can be thought of machines on wheels, construction vehicles, cranes, anything that's outdoors and is industrial machinery. And in those type of environments, like for example, a construction site, there's going to be a lot of noise, whether it comes from the actual construction vehicle.
And you're talking about electrical noise here, Eduardo.
That's correct. Yep. I'm talking about electrical noise. Yep. And specifically on a construction site, that electrical noise could be from a control system on a vehicle. It could be from motors on a vehicle. It could be from radios, from walkies on a construction site. So, specifically, mobile equipment approved sensors, they have a much higher resistance to electrical noise and EMC, and that's one of the main features of a mobile equipment sensor versus a non-mobile equipment.
And that translates into operational reliability.
Exactly, right. That it's much more reliable, and part of that is just due to the sensor with its self-monitoring and its and some other features that it has. But yeah, that's one of the features of the mobile equipment sensor in
Okay.
particular, as well as
Okay.
the wider operating temperature. Can't forget that.
Okay. Good. Temperature. Yeah. Tell me one thing though. Let's go one step back. Why and under what conditions should a customer, a user, an engineer even consider using a safety versus a non-safety? Why are there these two types?
That's a great question. Mainly, there's really two key times when you would want to use a safe rated sensor over a standard sensor. One of them is if it's a type of machinery that is always interacting or it comes into close interaction with a human operator. You need certain designs and certain safeguards implemented into the machine such that if something were to happen, if it were to fail in any type of way, it really, really reduces the chances of damaging the machine or hurting someone.
Yeah, I think one part that gets forgotten way too often is safety is not only, of course, it's very critical, very important to protect humans. That's of course clear, but it's it can be equally as important to protect some operational states on a machine. So one thing that I'm thinking about is imagine you had some type of an off-road vehicle where you have a pin that keeps a one of those I forgot what they're called where you can hydraulically move the loading surface to make material slide off. Imagine you have a pin that holds that in place, and you're not sure if that pin is engaged or not engaged, and you engage the hydraulics. I mean, the
Hmm.
forces that you create there are not only damaging the machine, but if there's a human being around and you're doing that and this thing explodes, very, very dangerous.
Yeah, it can be. Yeah, that can be catastrophic if it's not reliably detected and not insured for whatever it's monitoring.
Yeah, well, that's very very good. Now, there are, of course, we talked briefly talked about that. There are, of course, some sensors already out there that are safe rated. What is unique? There are a couple of things that are unique about our design. What are those?
Specifically for the safe inductive, one thing that's unique about that is one, it has the two redundant dual OSSDs. That's a that's a standardized type of safety output that's commonly used in a lot of safety sensors. And specifically for inductive, unlike, for example, a safe magnetic switch or safe RFID switch, you don't need any special type of coded target or any type of special actuator. You can use any standard piece of metal, and it'll pick it up like a regular inductive sensor.
Hmm. Hmm. So you already mentioned, of course, the deadband. That's quite unique that we don't have that. And then, if I'm not mistaken, our design also is a non-software design. That's very very different. Can you speak about that, please?
That's right. I mean, when you think of certain safety systems, like for example, AS interface, it's very software intensive. You basically have to know how to be a controls engineer, somewhat, to at least read the diagrams and read the instructions and integrate that. But for our safe inductives, they're self monitoring. So because of that, they have two redundant outputs that they kind of self monitor built into the sensor. So if something happens just on the sensor, if there's a fault on the sensor alone, the sensor will go into a fault state without having to rely on an external device to shut
Yeah.
down the sensor.
Yeah. And the other part that goes along with that is without utilizing software for safety, making the sensor discrete in design, our safe outputs are non-pulsed. And that is really powerful because there are some IO cards, some safe IO cards that are very, very finicky when it comes to pulsed outputs. And so having a steady output is incredibly valuable. It makes things very simple. The output is on when there is a target, and the output is off when there's no target. No state in between, no pulsing, nothing to worry about.
Exactly. Yep. You can basically take the sensor right out of the box and install it into whatever type of application you need, and it'll work right out of the box.
Great. Eduardo, I think we covered everything we want to cover in this short intro. And you know the rules. You need to think about a 5-word statement or so that captures the essence. And in the meantime, I'll try to summarize what we've talked about. Sounds good?
Yeah, definitely.
Okay, so here's my summary. So we're talking about a mobile equipment rated safety inductive sensor that is unique because it is a discrete design, no software, has none of the negative aspects that a software defined system brings along. For instance, the output pulses that are usually required. We don't need that. We also are capable of providing this sensor in an extended temperature range with mobile equipment ratings, very important for the rough and tough applications of the mobile equipment market. And also, that's kind of redundant. The deadband means that we have a defined sensing state. When it's on, it's on. When it's off, it's off. You know exactly where the target is. There's no, well, it's too close, therefore the output is still off. None of that stuff with our sensor. It just detects the target. Anything to add, Eduardo?
If I were to add just one more thing about the mobile equipment sensors, so
Please do.
We already had a series of mobile equipment safe inductive sensors, but we recently came out with a new generation of it. And one of the main differences with this new version is it can operate at a lower voltage. The first generation we had, the operating voltage was only 24 volts. This new generation we just released, it can operate down to 12 volts also. So
very good.
A lot nicer for our users, especially in mobile equipment.
Excellent. Yeah, I forgot that. Sorry. So, Eduardo, your 5-word statement, please.
Well, I'm going to cheat a little bit. It's 4 words, but I'm going to say reliable, safety, built in, and part of that is because of the software. You don't need any external software. Everything's built into the sensor, and because you get that definitive position of the target, you always know whether it's in range or it's not.
Yeah, excellent. Reliable, safety built in. I like it. Well, as always, Eduardo, I really appreciate the time that you took to prepare and have this recording with me today. And I'm sure I'll see you soon. Thank you very much, Eduardo.
Thanks for having me, Helga.
Thank you very much, everybody, for listening to today's episode of Pepperl+Fuchs Plugged In. And I'm not exactly sure what we're going to do next, but I'm sure it's going to be another great topic. Bye-bye, everybody.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.